Maybe I should first mention that artificial intelligence, even though it's useful now, it's really quite primitive and in infancy, in a sense that things that can be done by artificial intelligence are typically classification. Is something A or B? And there, for example, is a patient, does he have cancer or not? There, artificial intelligence is very good. But if things get connected in more interesting ways, then artificial intelligence or machine learning doesn't have the methods. And topology has that. So right now, people are busy trying to figure out how to connect the topology with machine learning in order to make more intelligent reasoning in artificial intelligence. Some 20 years ago, I worked with molecular biologists. They are interested in the shape of proteins. So here is one protein. It looks like nothing maybe, but it has a geometric shape, and that's how it interacts with the other proteins and the other molecules in our body. So understanding those shapes is very important. That's where geometry comes to play right away. We work at the intersection of computer science and mathematics, or maybe in a union of the two. That is, we work on geometric objects, low-dimensional like 2 and 3 and 4, but also high-dimensional. We work on topology, which is a more algebraic, more abstract part of mathematics, which is useful for geometric shapes. And from computer science, we do algorithms, so we implement things, we make it available, for example, if it's useful in practice. The high-dimensional data comes often from medical imaging, for example, or from medical data in general, such as cancer data, the kind of proteins that are involved in a cancer, and capturing the shape of such data in high dimensions apparently, or maybe surprisingly, is quite powerful. More recently, we go more in the high-dimensional direction, so doing topology for high-dimensional data. There are applications also, but I think a little bit further in the future, related to the new wave of artificial intelligence and machine learning and algorithms. I believe when those methods are better understood, then topology can play a big role and can refine these methods for the better or worse for the society. But I can tell you my experience that as my research got more theoretical, and I mean more abstract and mathematical, at the same time it became more relevant and applicable, which sounds like a contradiction, but I don't think it's a unique experience. So I don't believe in working towards applications, but rather doing fundamental research, but then realizing if something is important and applicable, knowing that it is. And that's the hard part. So the biggest challenge, I would say, is to understand why machine learning and artificial intelligence give such good results. Currently, there are no mathematical reasons. There's reasons of speed and so on, but nothing intelligible. But I think this is maybe the biggest challenge right now in the field.